So this is section 2.6, exercise 28. This looks sort of interesting here with the sports. It says for baseball diamond used in exercise 27. Well, okay. So there's the figure above it, and it says pretty much we've got 90 feet here. There's home, first base, second base, third base, and we've got a nice square that's 90 feet. It says, suppose the player is running from first base to second base at a speed of 25 feet per second. So if S is their displacement, or sort of like speed, ds dt, I guess, is 25 feet per second, they say. Find the rate at which the distance from home plate is changing when the player is 20 feet from second base. Okay, so they are here somewhere, and we know that's 20. And so, they're running along here, and as they run along, they have some distance from second base, a distance from home, and so we could do it maybe as a distance from second base. That might work. We need to relate these things. So, okay. So there's the distance there. There's the distance there. We could, and then I guess we could draw that to make a nice triangle. And I know that since that's 90 feet, then we can get a length here for that diagonal of the square, right? This is a square, and so that's just 90 times the square root of 2 in there. All right, we've got, well, I'm drawing it the other way, but we've got 1 square root of 2. And so, as we look at this, we could use this triangle, we could use this triangle. What's nice here is that's a right triangle. It's not clear what the best thing to do is. If I do kind of draw it this way and redraw things. So here's first base, there's second base, and you have that you are moving along here, and then kind of figuring out, so you're here, as you go. Well, so you might want to put home place here, right? And so that's 90, and here I guess I could call x, and this would be the square root of 90 squared plus x squared. This distance, and maybe let's see, so the way I've now drawn this is that's up here, dx dt is 25 feet per second as we go this way. Now the home plate distance, maybe I call that d, and what I know is that d squared, it's easier probably to do it as d squared, is equal to x squared plus 90 squared. So see, there I've gotten that relationship. Now the x here, though, you know, we're looking at distance from the base, not from first base, not the distance from second base. And so in our case, we're looking for when x equals 70. And you know, so there are a lot of different ways to come up with a relationship. As I look at things, you know, I like right triangles. They make things easier. You know, and I saw this right triangle there, but we had to recast our distance as distance from first instead of distance from second, the way they talked about it. And this dx dt does make sense at 25 feet per second then, because x is getting bigger. And so I have this relationship here. And so taking derivatives with respect to time, you just get 2d dd dt, and that equals 2x dx dt, and then plus 0 because the 90 doesn't change, so that's nice. And so the rate of change from home plate, dd dt, is equal to x over d dx dt. And so, you know, I know x is 70 because I had to recast it that way. And then the distance from home to the runner is the square root of 90 squared plus 70 squared. And then times dx dt, which is my 25. And so there's my answer, you know, whatever that turns out to be. Again, I can go to something like Desmos and calculate what that is. I'll get rid of these two things. And so I have a, whoops, no, that's not what's on top. Well, let's see. Go that way, go that way. Get rid of that. Okay. So that was, what was on top was the 70. So I had 70 divided by that square root of 90 squared plus 70 squared. Okay, and then that was all times the 25. So if I have those numbers right, go back and check. It looks like it's changing at about 15.35 feet per second. So that was 70 over the 90. Yep, there we go. So this is whatever I said, I think 15.35 feet per second. Okay, so that is number 28. And again, you know, so here I'm drawing various things and decided that the easiest triangle to draw was this one involving first base and home. And since this was what was changing, I made that x, I made that y, the y-axis and the x-axis, and then just had to get that length as a function of x. Okay, so number 28.